All right, so here is the practice problem or practice page that you're going to work through. So first thing I want you to do is just identify the type of reaction we're looking at. So here we can see we've got two plus signs on both sides of the equation. So I know it's not a synthesis or a decomposition type of example. Instead, I see I've got one single element here and I've got two elements here. Then from the two elements, I've got one of them single here, and then it's bonded to another one. So this is telling me here that I only have a total of three elements, and one of them gets replaced. This is going to be a single, S-I-N-G-L-E. I'm just going to write single because replacement is going to take a long time to write this out. So this is a single replacement reaction. All right. So after you identify what type of reaction it is, next I want you to balance the chemical equation. So this is what we're doing Wednesday and Thursday in class. I'm going to show you how to balance this one as an example, but if you need more examples on how to balance chemical equations, I've linked some videos under today's plans, and it's learning under that page that you've been working on. So let's look at Mg. So I'm going to draw my dotted line here. You don't have to do this, but if this helps you kind of divide the reactants and the products, that's fine. So I have Mg on this side. I have Al on this side, and I have Cl on this side as well. Same thing for my product side. Whatever elements I have on my reactant side, I'm also going to have them on my product side. So I've got Mg, got Al, and I also have Cl here as well. All right, let's see. Let me go ahead and change the color as I'm going to balance it now. So looking over on my reactant side, I'm going to count the atoms. So I have one magnesium atom from here. I've got one aluminum atom here, Al, but I've got three. Remember that subscript. We can't forget that. I've got three chlorine atoms here. All right, so I've counted the atoms for my reactants. Let me count the atoms for my products. So I start with Al. I'm starting here. I've got one for my Al, my aluminum. I've got one for my magnesium. And then I've got two for my chlorine on my product side. So now your next step, you've got to go through and see, are these balanced? Are these equal to each other? So when I look at Mg on my reactant side and I look at Mg on my product side, I see that they're even. So no need to add coefficients. Let me look at my Als now, my aluminums. I look at one of my aluminum on my reactant side. I look at aluminum on my product side. Those are equal, those are even. I don't need to change those. Now look, let me look at my chlorines. Oh, this is a problem, all right? But that's okay. We're smart. We're going to be able to fix this problem, right? So I look and see where I have the least number of chlorines, and that's the side I'm going to start adding the coefficients on. So I see that my product side over here has the least number of least number here. So in order to get this even, I've got to work with the least common factor between these. And between 3 and 2, it's going to be 6. So I've got to find a way to get 6 chlorine atoms on this side. And the way I'm going to do that is by adding a 3 to my coefficient here. Okay? Once I do that, once I add one coefficient, I've got to go back and recount the atoms for that side. So, right, all of these get changed now. So let's go look at that again. All right, so my aluminum staying the same. I didn't add a coefficient, but my magnesium's changed. I've got 3 now. Remember, that coefficient applies to all of the elements that it's next to. Now I have 3. I take my big number, multiply it by my subscript, the small number. 3 times 2 is 6. So I've got 6 chlorine atoms now. All right, when I look at my chlorines, let's just focus on that one for now. Those aren't balanced, but I can balance the chlorines on this side I can do that by adding a 2 here. And when I add a 2, I remember I said the common factor in between these two was 6. So 2 times 3, my coefficient times my subscript is 6. When I add a coefficient, I've got to go and change my numbers again. So now my magnesium is still 1. Now I have 2 aluminums and I've got 6 total chlorines. Remember, I've got to multiply the coefficient by the subscript. So I've got 6 chlorines, all right? So now let me just go double check, all right? Right away, I see, uh-oh, my magnesiums and my chlorines aren't aligned. So again, I look for the side that has the least amount. Right here, I can easily fix this. All I've got to do is add a 3 to my magnesium. Now I can change this, right? And because magnesium is by itself over here, it doesn't affect any other element. So I've got 3 for magnesium. Now let me look, and my magnesiums are balanced, my chlorines are balanced. Let's check the last element, my aluminum. My aluminums are not balanced. So what I've got to do is I've got to add 2 aluminums on this side. And again, this one's going to be an easy fix to this problem. All I got to do is add a 2 right here. All right, I've got the 2. So now I go and erase the original atoms, and I write how many I have now, which is 2, and those are balanced. This is probably one of the hardest chemical equations that you're going to balance because you're having to add coefficient, or in this case, one of the purple numbers, to every single element. That is not always the case, all right? So let's do one more as an example, just to be sure we really, really get this here. All right, so let's look at this one. All right, so this equation, let's first identify what type of reaction it is. So I'm starting with a no plus signs. Ooh, that's a good start, but I'm ending with a plus sign here, and I'm ending with 2 different elements. I'm starting the compound, I'm starting with one group, but ending with 2 different ones. So this tells me this is a decomposition one. And I'm just going to write D-E-C-O-M-P. Ooh, excuse my writing here. Decomp. I'm just going to keep it short and write decomp. All right. So now let's go balance it. I'm going to add my dots again, just so I know my products from my reactant side. All right. I have Mg I'm looking at, and I have Cl that I'm looking at as well. Same thing on my product side. I've got Mg I'm looking at, and I've got Cl I'm looking at here too. All right, so let's go and balance this. All right, so for my magnesium, all I've got is 1 on my product or reactant side, and I've got 2 chlorines. On my product side, I've got 1 magnesium and only 1 chlorine. Now, once I've counted my atoms, I've got to go check and see, are they balanced? So I see right away my magnesiums are balanced. Whew, that's good. I don't have to fix that problem. That one's already done. But when I look at my chlorines, oh, that's a problem. I've got to fix that, all right? And again, I'm going to start with the side that has the least number of coefficients, all right? And all I have to do here, only thing I have to do is add a 2 to my chlorine, right? And once I do that, I erase the original number. Now I have 2 chlorines, and now my chlorines are balanced, right? That is a much easier problem. I wish I could give you problems just like that, but I also know I want you guys to be able to really understand this and how to do this and be sure that you get really good at this. So again, I know this is difficult, but this is going to require some work from you. And if you do some really, really good work, you're going to see some really, really good results. So work hard, work together, and we'll continue to go over this on Monday.